We now talk about resistors in an AC circuit. So consider an AC circuit as in the diagram, and this AC circuit has a power source which provides the voltage V. Now since it is an AC circuit, this power source is sinusoidal. So you have this voltage V is equal to Vm times sine of omega t. So this Vm is the maximum voltage. So now we use Kirchhoff's loop rule, and from Kirchhoff's loop rule we have seen that V is equal to I times R. So I is the instantaneous current. So this I is the instantaneous current and this R is the resistance. So let us put this R as resistance here. So now you just divide by both sides by R, and instead of V you put Vm sine of omega t. So this is nothing but V. Now in place of Vm by R we put I of M. So this I of M is nothing but the maximum current, which is maximum voltage divided by the resistance. So you get equation for the current as I is equal to I of M sine omega t. Now both these equations have the same period omega t. So you have I of M sine omega t here and you have V of M sine omega t. So these equations have the same period. This is sine of omega t, this is also sine of omega t. And therefore they are said to be in phase. So that means both these equations follow a sinusoidal wave, that is they follow the sine curve. Obviously they have the sine in the equation, and both have the same omega t angle. So in the figure it looks like this. So this in red we will write as the voltage. So the red would be the voltage. So this red curve is the voltage curve V, and this is the maximum value of the voltage V of M. And the blue curve is the current, instantaneous current, and the maximum value of the current is I subscript M. And you can see both of them move in the same way. We now talk about the phasor diagram. So what is a phasor? The phasor is a vector with length as the maximum value of the variable it represents. The projection of the phasor on the vertical axis represents the instantaneous value of the variable it represents, and it rotates in the counterclockwise direction at an angular speed equal to the angular frequency associated with the variable. Now this is quite a mouthful to say, and we should understand this with an example. So the example we will take is of the current and the voltage. So we have two phasors here. So the blue phasor will start from here and end here. So this is the entire blue line. So first we just draw the blue phasor. So ignore the red part here first. Just think of it as the entire blue line from here to here. Now this is the current phasor. So the length of this phasor is the maximum value of the current. So the length of this phasor we write as I of M is the length of the phasor. So this is the length. So the length of the vector is the maximum value. Now you focus on the red vector. So this red vector is the voltage. So V of M is the length of this red vector. This is the maximum value of the voltage. Now it makes an angle with the x-axis. So you have x-axis right here, y-axis right here. So this angle is omega t. So the projection on the vertical axis, would be V of M sine of omega t, since this length is V of M. And similarly this I vector has length I of M, and its projection on the vertical axis is I of M sine of omega t. So you can see that this is nothing but the same thing right here. So this is what phasor is, and it goes in the anti-clock direction. So this rotates in the anti-clock direction. So rotation here corresponds to the wave movement here. So as you move in the waveform here, this thing keeps rotating here. Notice that in the phasor diagram, it is easy to see that both the current and the voltage make the same angle omega t with the x-axis. So that is another way of saying that they are in phase since they make the same angle. So keep this figure in mind for later on.